three parameters that we can measure using an analog multitester. So these are resistance values, current, and voltage values. So today, we're going to measure resistance values first. And also, I'm going to teach you how to read the values on the analog multitester. So since we're going to measure the resistance values, you could be able to use any of these resistance multipliers. So we have here multiplier 1, multiplier 10, 100, 1K, or 1,000, and 10,000 or 10K. So before we measure the resistance value, we have to calibrate first the multitester by simply connecting the positive and the negative probe. So it is necessary that the pointer points at the 0 value. Since the pointer is not on the 0 value, we have to adjust it using the ohm adjuster. But unfortunately, it is already on its maximum limit. So we'll try to adjust the needle. There it goes. Okay, and then we're using the multiplier 1. So let's say, for example, I'm going to measure the resistance value of this resistor. Assuming also that I'm clueless on the resistance value of this resistor. What I'm going to do is that measure the value using the multiplier 1 and then connecting my test probes in parallel with the resistor. By the way, this is a carbon resistor. So as you can see, there is no movement on the needle. It doesn't mean that it has no values. It's just that the multiplier is too low. Perhaps the value of this resistance is high. So what we're going to do is that we're going to switch the multiplier to 10. Apparently, the needle moves a little. So I want a more detailed value of my tester. So what I'm going to do is that I'll move my tester. When I try to adjust my tester or my knob into 100 multiplier, then I have to calibrate first by adjusting the ohmic knob until such time that the needle points to 0. So since that the needle points already to 0, then it means that we could measure now the resistance value using the multiplier of 100. So again, we're going to see resistance value. You have here 0, 1, 2, 3, 5, and then this is your 5 units. This is your 10. It's up to you to divide the line mentally. You can mentally divide the lines or count the lines of the ohmic value. The value of this resistor is 6 ohms. 6 ohms, then you have here the multiplier 100. That will become 6 times 100. It is equivalent to 600 ohms. The value of this resistor is 560 ohms. But based on our reading, of course, we cannot read the exact 560 ohms. If there's not much discrepancy or difference with the value, it's okay. So let's try another resistor. Supposedly, I would like to move to 1K. Okay, I make use of the multiplier 1K. I can also make use of multiplier 10, multiplier 1. But let's say, for example, I make use of multiplier 1K. So again, since I adjust the tester, I have to calibrate it and then adjust the knob until such time that it reaches the 0. Okay, so there it goes. So it's already on the 0 ohms. Then release. Then we have to measure the resistance value of this resistor. Okay, so to be able for me to demonstrate the display, I'll fold the terminals. Okay, so as you can see, the pointer points on this area. We'll read the values on the uppermost scale because this is where the resistance values lies in. So 0, 1, 2, 3, 4, 5, 10, and then this is your 10, this is your 20. So you'll try to divide each line. To be able for you to reach 20 from 10, each line will be represented by unit of 1. Let's try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 lines. So each small line will be represented by unit 1. 10, 11, 12, 13. So this is 13 ohms. But you have a multiplier 1K. Okay, so 13 times 1K, that is 13K ohms or 13,000 ohms. But in engineering, we made use of the 3 zeros as represented by kilo. So that will become 13 kilo ohms. 13 times 1K is 13K ohms. Okay, so let's move now to this LED. So let's try moving your tester to again, calibrate your tester. Okay. The needle points to 0, so there's no need of calibrating your tester. The short terminal is for the positive of your test probe. The longer terminal is for your negative test probe. The needle is on the 20 value here. So 20 times 100, that is 2 kilo ohms. So 20 times 100, that is 2,000 ohms or 2 kilo ohms. So that will become 2 kilo ohms. Normally, if it's 0 ohms, it means that the circuit is shorted. So let's say, for example, we try to connect the test probes positive and negative. You can see that the needle fluctuates to the 0 ohmic value. This means that it is short circuit. But if you try to disconnect, the resistance is an infinite value, which means this is a very, very high resistance, and therefore the circuit will be open circuit. So resistance is a very useful tool for determining if the circuit is shorted or open, if there is a defect on your circuitries, or even in your wirings, if there is a shorted or an open circuit. So that's all for now. Please watch my next videos for the current and voltage measurement. Thank you and God bless.